Okay, here comes question number 2. If the tip of a pendulum travels 330 centimeter in one full oscillation and the length of the pendulum is 105 centimeter, calculate the angle set by the pendulum in one half oscillation in degrees, and you can take pi as 22 divided by 7. This is a very simple question, but I have included to show the conversion from radians to degrees. First, let me describe the pendulum for you. The pendulum is fixed at point O, and when it starts the oscillation, the tip of the pendulum is at point A. The length OA is the length of the pendulum, that is given as 105 centimeter. And in one full oscillation, the pendulum strip starts from point A, travels to point B, and comes back to point A. And in doing so, that is, when traveling from A to B and back to A, it travels a distance of 330 centimeter. Now, while traveling from A to B, that is one half oscillation, it sweeps an angle theta at the point O. The question is, calculate theta in degrees. So that's the question which we have to answer. What is given in the question is, one full oscillation is 330 centimeter, whereas we have to calculate the angle for one half oscillation. Let us name the distance travelled in one full oscillation as L. The distance travelled in full oscillation equals, let's say, let's call it as L. So what is the distance travelled in half oscillation? Is L divided by 2. So the distance travelled in half oscillation equals L divided by 2. The distance travelled in half oscillation is the arc length AB, because the pendulum describes a circular arc while oscillating from A to B. The formula for arc length of a circle is r theta, and theta is in radians. How do we get it? Because the distance, the total arc length in a full circle, total arc length in a full circle, that is, the full circle is 2 pi radians, correct? That is 2 pi radians equals 2 pi r, correct? Therefore, the arc length in theta radians equals 2 pi r divided by 2 pi multiplied by theta. So this is the arc length in theta radians. So 2 pi get cancelled, so you have r theta. Okay, now we know L, we know r, we have to calculate theta. Let me call this as 1, 2. From 1 and 2 we can say that r theta equals L by 2, correct? From 1 and 2. From 1 and 2 we can say that L by 2 is the length of the arc A to B, and the same is given by r multiplied by theta. Okay, so from 1 and 2 we can say L by 2 equals r theta. Now L is equal to 330 and r is equal to 105. Therefore, theta equals, theta in radians, remember. So, theta equals L by 2R, which is, L is 330 divided by 2 multiplied by 105. Now, same in degrees. If you have to convert this radian into degrees, you have to multiply by 360 and divide by 2 pi. Therefore, theta in degrees equals 330 divided by 2 into 105 multiplied by 360 divided by 2 multiplied by 22 divided by 7. So this would be, let us calculate this. Now, 105, 330 divided by 2, okay, is 165. Now, 165 divided by 105, divide both of them by 5, you will get, I think this is 33 and this is 21. Okay, now you have this 21 and 7, so this will be 3. Okay, then we have this 22, 33. You have to divide by 11. So you get 3 divided by 2. So you have 3, you have 2 here. Then this 3 and this 3 will get cancelled. So you have 360 divided by 4. 360 divided by 4 is 90. So the angle swept by the pendulum in one half oscillation, that is theta, is 90 degrees. So let's move on to question number 3.